In this video, I'm going to demonstrate how to perform a scatter plot and a Pearson correlation coefficient analysis. The assumptions when we do these kinds of correlational analyses is we need two numeric variables, and we're assuming that the data within these variables are going to be normally distributed. And so in this case, we're going to look at math scores and science scores, and let's assume that we've already did the analysis. We know that both of these data sets are normally distributed. So our first step before we can do the actual Pearson is to make sure we've met the assumption, a couple of the assumptions for that analysis. In order to do that, we need to look at a scatter plot. So the first thing we're going to do is create that scatter plot. So we go down to the plots menu and we choose scatter plot. And in this case, very often it matters which is the X variable and which is the Y variable. But in this case, it doesn't really matter. A lot of times if we feel there's a temporal sequence to the variables, in other words, if your score on the SAT can predict your GPA, then score on the SAT would be the X variable because we're assuming that comes first, and then your GPA in college would be the Y variable or the outcome. In this example, it doesn't really matter, but in many examples, it does matter in the sense that you're trying to predict, does X seem to explain Y, or is X related to Y? So in this case, we're going to choose math scores as our X and science scores as our Y. And again, it doesn't really matter in this example. And since we're going to look at the totality of the two variables, math scores versus science scores, without separating them out by male or female or grade level or anything, we can use grouping variable, leave that as none. And then once we've got our two variables entered, we click submit. Okay, and then what we see here is the actual scatter plot. And so as you learned previously, each dot represents the confluence of two scores for an individual participant. So we took a group of people, we measured their math scores and their science scores, and then each dot represents the confluence of those two scores for that individual. And so as you can see here, we have a pattern that has developed. And so that's one of the things we want to look at, first of all, is does a scatter plot show some kind of a pattern? Do the dots appear to kind of travel from lower left to upper right? In this case, they do. Or another possibility is they travel from the upper left to the lower right. So there's definitely a pattern here. So that is a good sign. That indicates there's definitely some sort of a relationship among these variables. The next thing we want to look at is if this relationship appears to be linear. In other words, do the dots appear to be kind of traveling in one direction? And if we were to continue gathering more data, would that same directionality or that same linear relationship occur? If you see a situation in which the dots seem to be traveling pretty well in one direction and then suddenly they plateau or they even change direction, that's what's known as a nonlinear relationship, and then we can't do a Pearson correlation on that data. We could, but it would not be an accurate estimation of the real relationship. So we've met our two assumptions here that we really want to look at with the scatter plot. Is there a pattern? Is it appear to be linear? And then a third thing we can look at are what we call outliers. So as you can see, most of the data points are kind of clustered close to one another. If we were to draw a line kind of down the middle of this, most of the data points would be pretty close to that line. If we happen to see a data point way out here or way down here that is quite a bit removed from the other data points, then that would indicate we might have an outlier. But as I mentioned before, we've already examined for normality, so chances are we do not have any outliers in this case. But sometimes if we don't examine for normality, outliers may pop up in the scatter plot. So it appears we've met the two major assumptions that we want to use the scatter plot to examine, and that's the linearity and that there's a distinct pattern among the data. And we met one of the other assumptions, as we mentioned earlier, there has to be normally distributed data. So now that we've done this initial analysis, now we can actually do the Pearson correlation and get the R value that's going to give us a little more information about this relationship that we're seeing here. So in order to do the Pearson, we're going to go to the Analyses menu. We're going to find Correlations, and we're going to choose Pearson. And as I mentioned, Pearson is used when we have two numeric variables using numeric data that is normally distributed. In this menu here, we first want to add our variables. In this case, we're going to add math scores and science scores as the two variables that we're going to examine. And then we click Confirm. Now that we have our two variables entered, we can go ahead and click Calculate. And we're going to look at the raw output. So let's go to that option. And so there's three pieces of information that we can get from this particular output. The first, which is in the first, or actually the second column here, is the R value. This is the actual Pearson correlation coefficient, which gives us a sense of the strength of the relationship between these two variables. And as you learned in the lecture, R values can range between -1 and +1. And the closer they are to either -1 or +1, that indicates a stronger relationship. So as you can see here, we've got 0.96, which is pretty close to 1, which indicates a very strong relationship. And that was borne out by the scatter plot. We saw most of the dots really close to one another, and that's another indication of the strength of the relationship. Another piece of information we can look at is the confidence interval for this R value. And what this tells us is here's the range of possible R values that we could see in the population at large. So this was a sample of 150 individuals, and their R value between these two variables was 0.96. But the 95% confidence interval tells us there's a 95% likelihood that in the population of everybody, the R value would be somewhere between 0.94 and 0.97, which is good because that's a narrow confidence interval. And that tells us that the strength of relationship we're seeing in our sample would very likely be present in the population at large. So that's a good sign. And then the last thing we can look at is the actual p-value associated with this R value. And this gives us an indication of how likely it is that this R value we're seeing is due to chance. And so this is going to be a very small p-value. It's, let's see, there's going to be, looks like 8 zeros in front of the 4. So that's going to be well below the 0.05 p-value that we typically use to determine significance. So that tells us the likelihood that this correlation is due to chance is extremely small. And so we could say that this is a statistically significant correlation between math scores and science scores. So hopefully this makes some sense, and hopefully you've learned a little bit more about correlations from this analysis. And we're going to get into quite a bit more depth as far as talking about other ways to examine correlations and how to characterize them as we get farther into the semester. So let me know if you've got any questions, but hopefully you found this to be an informative video.